Welcome back for section 2.2. We're going to learn about set operations in this section, and there are 4 operations that we're going to learn. So these are different things that you can do with a single set or 2 sets to combine them together or alter them to get a new set. So the output will always be a new set. So each of these, here's the 4 names. We're going to learn an intersection, a union, a difference, and a complement. They all have a special notation, so a symbol that denotes them. And then we're going to give the definition for how to tell or how to create what is in that new set. So let's go ahead and start with the intersection. So the intersection, the notation we're going to use is we have a set A and B. So to do A intersect B, we're going to put sort of a large, it's kind of like an upside down U in between them. So this is A intersect B. Now, I want to help us use the words that are used to help us think about what the definition should be. When we think about the word intersection, think about places that you've heard that in the context of life. One of the first things that might have come to mind was like in roads, right? You have intersections between 2 roads, which literally then looks like where those roads cross each other. So what I want you to think about when you think of intersection is think about overlap. So when you think of intersection, think about overlap. The definition is the intersection, A intersect B, is the set of all elements in both A and in B. It's the overlap. It's the set of elements that are in both of the sets. So the elements common to the 2. Now let's take a look at our next one, the union. The symbol for a union, nicely, is like a large capital U. So a union, you might remember as that large capital U symbol, and then you might remember intersection as being like the upside down of it. It's kind of similar to our logic symbols that we saw in the past. There are a lot of analogies between the 2, so you could think about those. Now again, let's use our context of things around us to help us think about what this definition might mean to help us remember it. When you think about a union, if you think of other places you've heard that word, well, you might think about like a workers' union, or you might think about like a union in marriage or something like that. But typically when we use that word of union, what we're talking about is this concept of bringing things together. So this concept of taking multiple things and grouping them into a single group, so kind of lumping everything together. So keeping that in mind, a union B is the set of all elements in either A or in B. In either A or in B. So as long as it's in one of them, it will end up in the union. So you'll combine them all together to create a union. Now a difference, if we think about that word, you might even think about the mathematical word difference. Might be the easiest way to help us connect to this idea, where a difference mathematically with numbers is a subtraction. It's kind of like the same concept here. We even use the same symbol. So the difference is going to be like A minus B. A minus B. This is the set of all elements that are, we're going to do in A, but not in B. So you're going to literally start with the set A and then subtract out the elements that were in B. You'll eliminate some of them. So it's like a subtraction. The last one we have is the complement. Now, when we read that word complement, it's like the idea of my skills complement your skills, not the idea of I'm going to pay you a compliment today, although that's always a nice thing to do too. But when we think about complement in that sense, like my skills complement your skills, it's sort of that idea of opposites, right? You have the two different pieces that together make the whole, but they are opposites of one another. So that's what we'll kind of keep in mind. A complement is for a single set, and the notation we use is called a prime, but it's sort of like an apostrophe or like a comma to the sky, if you will. So we read that as a complement. The set of the A complement is the set of all elements not in A. So it's the opposite of the set A. It's everything opposite of it. Now, we do still need to be careful that we're not in A, but still in our universal set, right? We don't leave our universe. So it's basically the other half of the other elements that would be outside of the set A when we consider them in that universal set. So that's our complement. We've talked about kind of these ideas and these symbols, but let's actually try an example with some particular sets to see how this is going to work. So let's say, for example, that we have sets A and B, and then we have some sort of universal set. So let's suppose that set A is A, B, C, D, and E. Let's say that B contains A, B, F, G, and Z. And then we'll say that U contains, the universal set is A, B, C, D, E, F, G, H, I, and Z. Now we could have used U as, we could have created these sets to be anything we wanted. We could have had U be the entire alphabet, but I chose to just make it this particular portion of the alphabet. So let's put all of these into practice. So let's find these different sets. So let's just go in order. Now our first one, that upside down U symbol, remember, is the intersection. And when you think of intersection, you think of overlap. So what is common to both of them? Now, notice when we do these, we are getting a new set. So I do need to start this with an opening curly brace to write down what the set will be. So all we're going to do right now is look between the sets A and B and look for what's common to both of them. So notice they both have an A, they both have a B. A has C, but B doesn't, nor D or E. B has F, G, and Z, but none of those are in A. So the only letters common to both sets are the letters A and B. So at this point, we'll close off our set at this stage. So our intersection is A, the set containing A and B. We could then look for the union. So A union B. Now remember, with a union, it says lump them all together. So take anything that's in either set. So we could look through them. I could put it all in alphabetical order, or it doesn't really matter. We could just list elements from all of them. So I could start with, say, well, set A has the sets A, B, C, D, and E. And then I could just keep going now looking at the set B. Now notice, do I need to rewrite the element A again? Well, no, because it's already there. And remember, all that matters is, did we write it or did we not write it? So A is already there, B is already there, but F is new, G is new, and Z is new. And at that point, I've listed everything. So notice, this is like a collection of anything that was in either of the two sets. Now they're all lumped together in one new set. All right, let's look for a difference. So let's say do A minus B. What that one means is we're going to take, remember, the things that are in A but not in B. So starting off with the elements of A, my set of options are those 5 listed up there. So then we can ask for each of them. So for the A, do I keep the A? And we would say no, because it's in B. Do I keep B? No, because it's in B. Do I keep C? Yes. C is in A, but not in B. Do I keep D? Yes. Do I keep E? Yes. Notice the other elements of B don't matter at all. So all we're doing is we're starting with A and we're eliminating certain elements. I could, notice, do the other order, and I would get a very different result. B minus A would now be keep the things in B, getting rid of anything that's in A. So it needs to be in B, but not in A. So we're going to look at it in the other order. We'll read the list of B and figure out what to keep. So do I keep A? No. Do I keep B? No. Do I keep F? Yes. G and Z. So those would be my two difference sets. And then let's just practice a single complement. Let's try a complement. So remember, we want everything that's not in A, but we still have to be in our universal set. So we have to stay in our context of our problem, but we want the opposite of the set A. So really what we're going to do then is we're going to look at our universal set, and we're going to take everything that's not in A. So do I keep little a? No, because it's up here. Do I keep B? No. C? No. D? No. E? No. But then I will keep F. I will keep G, H, I, and Z. So we're taking everything that's in the universal set that's not in A. So get rid of all of the elements of A. It's almost as if we just crossed them off and said, what are we left with? Go ahead if you need to relook at this example one more time. Take a minute to do it. And then when you're ready, you're going to go to your worksheet for section 2.2, and you're going to work through the first question on there. It's like this one. It gives you several sets, and it asks you to find various operations of those sets. So again, give it a try on your own first, and then take a look at the next video when you need some help or when you're ready to look at the full solution.